Hello everyone, I'm Xiao Gang. Let's go through the documents in one go, just these few documents. We'll only pick the useful parts to talk about. We've actually used FName before. In the editor, it looks like this. Let's open the level blueprint and create a FName here. You can see it's purple, and it has some features. It's often used in dynamic material instances, like the one with a shuttle effect, the name of the digital parameter, and we'll use it in the Google socket name. It's a string used by a lightweight system. Then, in this word system, this string will be frequently used, so it is stored only once in the value table. It is case-insensitive and immutable, and cannot be manipulated. The storage system and static characteristics determine it uses this key to perform FName. Look back and reverse lookup speeds are very fast. And then it uses this hash table method to provide fast string operations, so it is actually somewhat similar to that kind of unique, that is unique and singular, that one-of-a-kind ID used to identify a certain name of an us, and it is case insensitive. This is our FLAM. And as for this FText, it is mainly used for localization or when formatting text. We will do such things. Then, and as for this thing, it is when we hope that external APIs can handle these texts, perform a batch conversion, or when replacing. It is very convenient. Then you can click here to see. Actually, part of the content is placed in this position. That is in the localization section. You can see a large amount of content here. And actually, regarding FText, you only need to master this red. And this red, mastering this part of knowledge is enough. As for the rest, actually, at your current stage, this is often used in our blueprints. So, we're going to trim some content within this text, right? As for the rest, actually at our current stage, you don't really need to worry about it. And then regarding this conversion into this kind of time-based substring, sometimes we might find it useful. Yes, we might need this later on. Okay, so actually these things, at your current stage, you don't really need to look at them because you can see it involves a lot of languages, and regional culture is actually quite complex. And these are some of its own built-in macros. Okay, then finally, we look into the details. Let's go back to this place. So for FText, it is especially useful when dealing with our local culture or formatting text, and FString is what we commonly use. So it is the subtitle string type that we often use with other languages or in other engines. It has the same functionality. In our previous I think it was demonstrated to you all. FString can also be searched and modified. These subtitle string comparison features, but because it is variable, so it definitely needs a buffer. It needs to remember things like concatenation, so its overhead is definitely not smaller than FLM. Then because FName and FText both store this kind of shared subtitle v-pointer, and equality can be re-established based on all shadows, whereas our FString might need to follow dictionary order and compare letter by letter. So this is a characteristic of FString compared to them, a feature. Then as for point 4, 这是下和所, we can use some symbolic formatting methods to replace things in FString. Then this place provides some conversion example. Then you'll notice you can't see it here, right? Actually, how do you make it visible? You copy it over, change this language. This language, it can be seen here. Convert it to English. Then this place gives some common commands. UEC, for example, converting a float to an exec. Very simple. So this float has its own toString method. And if you want to convert it to text, you can directly call the static method from FText. And what does it mean when it's highlighted in yellow? It means you will lose data because you're fixed. It has some localization information. But within FName, it actually does not have this localization cultural information. Similarly, when converting from FString to FName, there is a case sensitivity issue. When converting to FName, this situation occurs. Then convert FString to FText. Here you can directly construct the parameters. That is, it has a constructor that can specifically handle the situation. And here it can generate an FText from street. Then extracting SText2 is actually very simple. Just directly to print. But FText cannot be directly converted to FLAM. However, we can convert it to string. You just need to go through one intermediate step. Okay, so in this case, how do we convert between int 32 and float? We need to use another class called cstring. That is O2I and O2F. They can pass a character not counting. Convert it into the corresponding numeric type. When converting back, you don't need string. You can directly assign to int or satellite float. And there are some encodings here. Then we switch back to Chinese. The meaning of this encoding is that you should try to use this FTXT macro as much as possible. Of course, you don't have to use this macro. You can directly use double quotes to mark strings. We sometimes do this too, and it's fine, but it will be limited, because only when you use the FTXT macro can you complete this encoding conversion to use it more efficiently. Okay, so overall, that's it. Then let's just go through it all at once. Let's take a look at this string encoding. As for this document, you can read it on your own later. Check the official documentation. I have already emphasized this to you in detail. No matter what you do, as long as you are a developer, you must master this area of knowledge. That is it. Then let's talk about. Let me explain to you this character, how it comes about, how it is stored, and then between different characters, how they are converted. You can see, but actually for us, this is a basic skill of yours. It really tests your fundamental. Very complex. You need to calm down. Read it patiently and carefully. Read what it is talking about. We won't read it together with you here. Okay, then let's take a look. This part is about character encoding. Before we talk about it, let me tell you, you just need to know what it is. Let's take another look. Let's retrieve it again. That is, if you are in UE5, you need to know. That is, you need to use NC and UTF-8, and also UE's own encoding. You need to know these three. Then you don't need to worry about JBK or anything else. And there is also binary. You just need to know this Z, and this UTF-8, and UE's own encoding. These 3 plus binary, that will be fine. We won't go into the rest. Let's look at the key point. This is a feature of UTF-8. You can pause and read it yourself. Because this is quite complex to read, yes, then we are mainly concerned with this. The string representation inside UE5. In the UE5 engine, in the Unreal Engine, all strings are stored as string or TCHAR values in UTF-16 format in memory. So when you store it this way, then actually you need to. Then in the storage and reading methods, you may need to do it in UE5's own way. Then you can see, later it introduces UE5. He reads it himself. These R&R files are files that write R&R. He does it through this kind of API. We can take a quick look. You see, we search globally like this. Let's check the location of this API. Let's take a look. It seems like it's not found right. That's a bit awkward. It is in this umes.cpp file. This might also be due to the golden circle recognition. Let's take a look. If it's still not there, let's see if this file still exists. Then let's search like this. Take a look. If it's not found here, we'll just ignore it for now. It's enough for you to know that there is such a process. And actually, when we use it ourselves, we will use the FName class to handle it. But we'll cover later. You don't need to worry about. So note this point. We should not use these string literals. In our source code, sometimes we tend to hardcode a string here. This is actually not good because first of all, it's hard-coded. And when you write in the original code, if you write some Chinese, there might be some issues that are hard to fix. The correct way, you can use some INI methods through our conf classes to read and write configuration updates. This will also be covered. That is, we will explain to everyone how to explain to them how to write such a class and put it in these. Because I noticed many of them are inside plugins. When we write our own plugins, we can also write such things. Put it in this place completely. No problem. Okay, this is about get performance. Just ignore it. And the key is to look at these. These few red ones are very useful. But I can tell you clearly now, don't use it. It will have issues. It will have some issues. What specific issues? We go into detail later. because we're still going through the document, let's switch to this chapter. Look at this name. As the name suggests, it's about how to convert between our three types. Actually, what are these three types? They are TX and UTF-8. These four red ones can satisfy all our character encoding conversion needs, but these things are already deprecated. They are already obsolete, and we should correctly use string cost. Actually, this one is also obsolete, but we sometimes still use it. But the correct approach is to use string cost. There is a long string of comments here. Then later, when we talk about encoding, we'll cover it during the practical session. Yes. Okay, so this is where it's defined. That is these helper classes. How they work here in our string coin position. You can also see its path. It's here. It's under our container here. How it performs some conversion to help you. A string encoding conversion. The most important point is to look at this. Actually, there is a touch to AST conversion here. So you pass in an SS converted into our new char parameter. Then it can be converted into the intermediate struct. Then you can get its instance and its length. Then you can use it here. The problem with these macros is that they might, because this thing, it can only be used temporarily. That is it. Its life cycle is very short. So don't take this pointer and use it everywhere, because once it goes out of the scope, it will be released or truncated. Then it will cause problems. It gives you a pointer, but if you use it elsewhere, then we can take a look. Maybe it's not here. It's equivalent to the object the pointer points to. After this scope ends, it gets released. This is about encryption. This place seems... Let's see. Okay, let me emphasize this to everyone. You will make mistakes, and this part is about some uppercase and lowercase letters. We'll just ignore this. Then there are some specific Southeast Asian and East Asian encoding issues. Actually, we can also ignore these. Okay, so after we finish discussing this, in the next few lessons, we'll talk about these three things. What is written in the documentation